Does this look different? I feel like I look brighter, like it's a new day or something. It is a new day, but that's whatever. Who's this? Oh, grandma. Fuck. I didn't mean to open that. Sad. Sag. Can I mark that on red? Can I refund my red receipt on that? On red for me, but would it be red for her? Whatever. Anyway, ignore that. It's day 2. We did the Roman to integer problem. As a review, this problem was actually pretty easy. I couldn't solve it in 30 minutes. But what I did understand about it was, first we need this mapping of Roman characters to ints. And I kind of want to solve the integer to Roman problem too, to understand like the back and forth they had in the solution. But besides that, basically we're looping over the string of Roman characters. And there's 2 scenarios, right? There's a scenario that one of either I, X, or C comes before VX, LC, or DM. And in that case, you're going to take the higher number and subtract the lower number. So that's what this is down here. And so we're taking the higher number is the second number. So assuming we have 2 numbers to look at, if our pointer is less than length of s minus 1, and the current number is less than the next one, assuming those conditions are true, then we take our next, and let me actually go over an example of this. So for example, IV is a case, right? So assuming we have 2 letters left, so at this point, pointers would be 0, 1, 2, 3, 4, 5, 6. This is a length 7. 1, 2, 3, 4, 5, 6. Okay, 6. This is 7. This is a length 8, index 6. So that meets the criteria, because length minus 1 would be 7. Our pointer is pointing to 6. So we have at least 2 characters left. If we don't have 2 characters left, don't even run this check. Then we look at the next one. So for example, I was 1 is less than 5. And that's the only scenario we're going to have when we need to subtract. Otherwise, it's going to be decremental, a decrementing order, decreasing order. So we do our subtraction and we add that to total. We're adding the subtraction to total. We can do the sub. We can do an add and a sub or whatever you want to do. But the point is just the math is the same. Just pick a mode and stick with it. They move the pointer up 2 spaces because we're not going to look at the IV again. That's something with XC. Otherwise, most times we just add whatever the number is to the total and move the pointer up 1. That's it. That's the solution. That's the problem. I don't think I submitted yesterday, so we'll just submit now. Cool. So back to the problems on LeetCode. I was looking up, I need to bookmark that list actually. It was problems, it was tags, there's string problems, easy, ordered by frequency. So I solved that one. So we're gonna, problems, LeetCode. I can just call it LeetCode, right? I guess. All right, we'll look at valid parentheses. We have 30 minutes to solve it. 30 minutes, am I recording? I'm recording. 30 minutes to solve this, at most, until we get that tick, that itch for string problems. Okay. This one I think I have solved before. Maybe. So there's a solution, there's solutions and discussions. And there's a valid LeetCode solution, so I'm going to open that up in a different tab. Timer goes off, we have 30 minutes. I'm going to watch a movie after this. All right, so normal steps are to read the problem and restate it in your own words and get clarification. There's no clarifications here, but we can get some, some constraints here and maybe some other caveats in the description, but we'll see that. So first, let's read the problem. Given a string S containing just the characters open and close parenthesis, open and close curly brace, open and close bracket, determine if the input if the input string is valid. An input is valid if open brackets must be closed by the same type of bracket. Open brackets must be closed in the correct order. Every closed bracket has a corresponding open bracket of the same type. Okay. Exhibit A. Open and close is valid because open brace must be closed by the same type. Open braces are closed in the correct order. Every closed bracket has a corresponding open. So this is valid. That's why it's valid here. Then there's exactly the same one here where it says open and close, same type of bracket. So we're not closing a curly. We're not closing a regular parenthesis with a bracket or a curly brace. And then we're saying that also every closed bracket has a corresponding open bracket. So every closed bracket or curly brace parenthesis has a corresponding open. Now that's why it's true valid. Now this one's invalid because our open parenthesis is being closed by a bracket. I probably had another test case where our open parenthesis, you can close it here like that, but then the open one isn't open properly. It's another test case. But to reset the problem, essentially we're checking to see if we're returning the validity of a string based on whether or not these three conditions are met, right? Based on, so how do you even summarize a problem that has many conditions? We're basically validating that every open bracket has a closed bracket in the correct order. And that every closed bracket has an open bracket, and then as my phone goes in the room, usually, that every closed bracket has an open bracket as well. Problems seen at Amazon, BlackRock, and Adobe, as well as other problems too, like Google, Facebook, Microsoft, Apple. Okay, cool. Let's take a look. So, put the whiteboard out. Sorry, my lamp is being weird. Oh my god. No editing, guys. One take, Drake. No editing, no format. I just kind of do the problem and record everything. Okay, so we get a string. Open, close. Why is this valid? Well, why is this valid? Well, we have an open that's followed by a close of the same type. For example, if it was a test case 3, this would be invalid because it's an open followed by the close of the wrong type. But it would be valid if it was the open and an open of a different type, right? So if I did another test case, we'd say something like this. Be a parenthesis and then parenthesis. That's not yet valid, but this is okay as long as we close it in the correct order. So we have to then close the curly brace and then this. So that's also a valid case too. But it's also invalid if, okay. How do you tell it what? Oh, it's kind of weird. I was gonna ask, how do you tell it what you want it to return? Like case 1 should be valid, and it knows that. So what about my other cases? It just kind of knows invalid or valid. I guess it runs it against its own. I guess it probably just has to run it against its own coded solution versus like what you tell it. Versus when you're actually developing software, you don't have another function to call to validate your code. You have to validate it through the test. So I guess that makes sense. Anyway, okay, so let's start with the easy solution, right? The brute force or the straightforward one. So we have our test case 1 with the open and close right away. Is it gonna die on me? Maybe. Ooh, shit. Might die on me if I don't finish this early enough. Okay. A little motivation there, a little urgency. Okay, so if I look at an open parenthesis, I would expect to see one of two things. An open of a different type or a close of this type. So we have some branching there, right? That's probably an if statement of some kind. How we're going to store this stuff, I'm not sure how we're going to track everything, but let's start there. Okay, So if we have an open parenthesis, the next type has to be either of a closed parenthesis, or if it's not, then we're assuming we have, okay, so let's say there's a dictionary that holds the types of opens that we have and their corresponding closes. So we've got this regular parenthesis, curly brace, and a bracket. Corresponds to their closing counterparts, okay? Their corresponding counterparts. This is actually a different sign, but I don't know why I use that sign. Okay, so if I look up the open brace, right? If I say, let's say I have an open brace. If next equal to, say, dict at open brace, then this is valid and we can move forward, right? If it's not that, right? Let's say if next is not, we have a mapping here, so we can say like, if it's not a close and it's not in our dictionary, well, we already know it's not there. So let's say if next, we'll say not in our mapping, then we return false, right? Because then we know that, okay, it wasn't a corresponding close and it's not another open. So there's no chance it's even valid now. So we just return false here. Okay. Now let's change up the game a little bit, right? Let's add a little more junk and see how that looks. Let's add more characters and see how that looks. So we've got open. Let's say we'll do another open. And we'll do a close. Okay. So I've got this other string now with an open parenthesis, open curly, open bracket, close bracket. So this is valid. Close bracket, close curly, close parenthesis. It's a valid string. But I want to learn more about multiple opens and how we do that, right? Okay, so let's say we're taking a look at our first open parenthesis. It's valid. Okay. So it's valid to have an open parenthesis to start. That's perfectly fine. Then we look at our next one. It's a curly bracket, curly brace. That's also valid to have, and the open bracket valid to have. Now we look at the closed, and we know that our previous character was an open bracket. It was a closed bracket in the third index of the string. And so we need some kind of way to keep track of what we've already seen, so we know whether or not this is a valid character coming up in our iteration here. So I'm thinking some kind of array, and I know that arrays and stacks in Python are kind of used the same. So I'm not sure if we're going to use it as a stack or as a list, but we might. So let's take a look. So if I have an array of items, we know that as we look at them and they're valid, in this scenario, we really just care about having this bracket here. But in this case, I guess we can just add these other ones too, knowing that we've seen them before. So we know that we've seen these open, right? We've seen these open. What am I saying here? That we're seeing these open parentheses, brackets, curly braces, right? And we hit this other one that's a close. Seriously? OBS drains battery, bro. I'll just plug it in. Fuck it. Breaking my flow. So you plug your stuff in before you even start. Because otherwise you're going to have to get up in the middle of your session. Whatevs, it's fine. Okay. All right. So we have this. Okay. So when we get to the closed bracket, our previous, or I guess most recently added item was an open bracket. So this is valid. We're okay with this, right? This is valid, and we no longer need to check this because we know it's valid. So I guess that feels like a pop. Feels like a stack. Okay. I'm seeing stack behavior. We get our next one. It's not an open, right? Or let me. My logic seems flawed here. What's going on? So I said before, if our current character is not in this dict, that means it must be a closed parenthesis. And a close is only valid if we have an open on the stack that matches it. But if the stack, okay, so, okay. So if our stack is empty, if our stack of open parentheses is empty, and we get a close, return false, right? So if stack empty and I'll say cur not in our mapping, then return false. What is this what is this scenario? It's this. Our stack is empty and we have a close bracket or parenthesis or curly brace, whatever you want to call it, whatever you want to do here. Either way, it's going to be invalid. Cool. If that's not the case, then we for sure have an open. Okay. So if the stack is, it has to be empty and it's a close, or yeah. But how we know it's a close is if it's not in one of our keys. So we know that if it's empty and a close, it's over. If these aren't the cases, that means that the stack is either not empty So either the stack is not empty, and we have to check the validity of the character that just came in. So for example, so once we have this code out of the way, then we're basically saying that, our stack is here, our mapping's here. So this is the first piece of code I can write, actually, like for sure, right? Actually, writing code before I have a solution is bad, right? Or hasty, so don't do that. I have no code down at 14 minutes. Tough. Okay, cool. So if our stack is not empty or this is not a close or it's an open, we're safe to continue because we might actually be able to make this, but it might still be valid. Okay, so what else did we check? Well, we have previously before that if it was in it, then this is a valid character, I guess. Okay, so this is part of the questions I probably would ask. Can we get any other characters besides parentheses? Okay. If we can't, then we don't have to check for like it being in it too often. But there's no other hints here, so this is fine, I guess. Okay. So our stack is not empty, or this is an open parenthesis. So in that case, we have an open parenthesis. We're basically saying at this point, this string is still valid. So I think the first thing we're gonna do is add to our stack. So add cur to stack, right? What else? Is that it? Well, no, we can't add cur to stack yet. Yeah, we can't add cur to stack yet. Let me rearrange this code a little bit. I'm running out of room here. I'm running out of time as well. Time is a factor, man. Don't be a bitch. Life's unfair and then you die. Right? So if stack not empty, and we have a closing parenthesis or bracket, return false. As we're iterating over the list, right? As we're looking over the string list of characters. So this is not the case. That means that we have something in the stack, or this is an open bracket. Right? Is that the case? Is that the case? I feel like this is coming prematurely. I don't know why. I feel like this is premature and I'm not sure what's going on with this. So, the state of the code would have to be it's a close, return false. So if we have an open, so then we'd say if, cur in mapping, if it's an open brace, add it to the stack. Yeah. If the stack is not empty and it's not an open brace, that means it must be a closed brace with potentially matching open braces. So that means that we have another branch. I'm not sure how the branching is really structured, but we've got a couple cases here. So now we're on the third case of it being a closed parenthesis on a non-empty stack. I can just say else, I guess. It's not in it, so it must be closed, and it's not empty, which means that it's a potential match, but it only matches with the most recent. You can't go around it. I can't have an open parenthesis, open bracket, and then close with a parenthesis. I need the bracket first. So we're going to pop the most recent off the stack. I'm going to say, is this, if our current is a close, then we know, is what we popped equal to what we're currently looking at? Or I'll look it up in the mapping. Is what we popped and look up in the mapping equal to what we currently have? And if so, continue. If not, return false. If yes, take it off the stack entirely. Right? If no, return false. Okay, let's walk through it again. Okay, so if stack is empty, if stack is empty and we have a closing brace, return false. Not true. We've got, this is in there, so add to our stack. So our stack becomes open parenthesis, right? I'll even do like a real stack. So our stack becomes open parenthesis. Stack is not empty, so skip that. Cur is in it, curly brace. Stack not empty, skip that. Cur is in the dictionary, so we have a bracket. Stack is not empty. Closed bracket is not in cur. That means that this must be a closing bracket, so it's an else statement. So we're going to pop off the stack. Our pop now returns a bracket. And we're going to look up that it's a closing bracket that corresponds. If our current, which is a closing bracket, is equal to a lookup of a closing bracket, an open bracket, which is a curly bracket, then this is valid, and we can take this off the stack entirely. Okay? We can keep it going. And the pointer, if we're using a while loop for these strings normally use while loops. Since looking at the next isn't, maybe, I don't know, I'm not sure. I don't have a twitch yet for whether we choose a while loop or a for loop. Because we can always just break out of the function return false. If we do a while loop, it's increment. So I'm not sure. But anyway. Cool. Our next character is a closing curly brace. Stack not empty, skip. Closing curly brace not in the keys, skip. Pop it off. It's an open. Look up the open, which is a close. Everything matches. Okay, so this is gonna work. That's fine. So the solution works for the good case. Let's add a bad case to tag one to the end of this one. So let's add an open parenthesis and a closing bracket. Okay. So our stack is currently empty, actually, by the way. So if our stack is empty and we have a close, return false. Our stack is empty, but we have an open, and it's in there, so add it to the stack. Okay. Our stack is not empty, skip. The closing bracket, which is invalid, is not in our keys, so skip. Go to the else, pop this off and look it up. Is a closing parenthesis. Is that equal to this? No. Therefore, it's a return false. Okay. That works. This is it. Now we're gonna use a for loop or a while loop. Since we can exit whenever, a for loop is valid, and we're not looking at anything in the next. We're not looking up the next character ahead of time. So for loop, I think, is perfectly valid here. So I got a solution on paper in 20 minutes, 22 minutes. Okay, so we're gonna say, I can call it OpenStack, right? OpenStack is a list, and our mapping is a dictionary of this to this and this to this and this to this. Okay. When you say for, say C in S, say if length of stack equal 0. So if it's empty and C open parenthesis stack, right? And if C not in mapping, return false. That's that case. Then we say if C in, if it's an open one, then we'll say open stack dot pop. You can say append at, I can say 0, right? Oh, append. It's not valid. What is it? Isn't it? Oh, isn't it insert? Yeah, insert. What's the order? Index. Insert C at 0. Else we have a close parenthesis. So we got to take what's off the stack. Go look at mapping. So mapping at OpenStack dot pop at 0, which is, we can also say else. So if what comes off the stack is equal to what is here, so it's a lot of nesting too, isn't it? Might clean up later. So we're saying if our mapping is in there, cool. Then we can, well, a pop just removes it, right? What's a pop do? So peek. there a peak function? If you need to use your way to solve this, please return S stack rather than return. Okay, so we can just call. So we're gonna grab the last element off the stack and see if it's open. If it is, then we'll just say open stack dot pop. Else it wasn't. We return true. This is valid. Okay, let's see if this works. Ooh. Why did this fail? Probably because our stack was still had an item on it. It can also be invalid if we left an open on it. Okay. We got false. Ooh. Why do we have false? Well, open stack is not equal to 0. So what didn't we pop properly? 2 minutes. I don't know. Printing right away is kind of weird. I don't like that. Printing feels. What is this? Oh. So if you grab from the back, then it should be the. This is valid. Yeah, this is valid. This is valid, right? Am I crazy? No, this is valid. My grab isn't working properly. It's not really a pink function. There's no peak function. I have to grab stack at -1. It grabs the last element. We want to grab the first element actually. Yeah. Well, I don't know why I did that. So pop it. Okay. There we go. Submit. I'll need to delete that, by the way. Are you lying? I'm actually getting so fucking good at this. I'm probably gonna fail tomorrow, but that's fine. Are you kidding me, bro? Are you kidding me, bro? I did it, guys. I did it. Runtime 40 milliseconds. Beats 74%. Memory beats 72%. Because we have a stack and we have. I love this. This design is great. Company tag is great. Other solutions, great. Autocomplete, great. Autocomplete's nice. Debugger's okay. The company, I think official solutions are good too. And then runtime memory. But also the test case console. Love it. The least favorite ones. None of the above, please. This is sick. Guys, I did it. I wish I had like music to play off or something. I solved the problem. Now this problem I had seen before, but I forgot the solution. I knew there was a stack involved, and I knew there was a mapping involved. So when you're dealing with validation, especially when it comes to order, it seems like stacks and mappings are worth it. Especially when you're looking up validity. But the stack comes into play because the order matters. The mapping comes into play because your inputs are defined. Without it, there has to be some logic to check what's coming in. But yeah. And what did I code up? Something similar, I hope. Oh shit, what is this? Time complexity, take a look. Well, the stack can be, and the time complexity, yeah, okay. So what do they do? So if it's in the mapping, checking for the stack to be empty. So what do? They put some actual type checking here. So type S, return something. Return, R type is bool, type S for check. Okay. I should include that in my solutions. But that's also implied. It's implied by the other things going on here. Let's look at redundancies. Let's see. If I look at it myself, I mean, checking the stack is empty, and we have a closed bracket, immediately disqualifies the function, right? If we look at the console here, and we modify test case to be something like this, it should immediately disqualify. What it does. Okay, but for what reason, right? Their solution has a mapping, a stack, looping through the for loop. If the character is in the map, if it's not in the mapping, what? So they did a closing lookup. So if the character is a closing bracket, then they called a pop anyway. I guess preserving it doesn't really matter because if it doesn't add up, if it adds up, cool. If it doesn't, return false. You don't have to put it back. So being afraid to pop is not, being afraid to pop it is like whatever. So I could just say, for example, if, right? If not, open. I could just say return false. That'll get rid of that nesting. I can also make this an elif and drag this up one, like so. Cool. Because the pop, yeah, so you can't be afraid of the pop. And me realizing that and making the adjustments is sick. So they did the opposite way. They put the closing bracket as a lookup, which is cool. Yeah. So they mostly append it if it's closing and it doesn't map. matched on the bracket, false. Otherwise, it most likely will just be opening. So my scenario, I could say like, since we're always doing like, and the pop returns can return like nothing, right? This pop could return something invalid, but this is I think it's a cool function. Returns an unknown, not sure what we're gonna get from that. Okay. Ow. I think it's fine. Yeah. Cool. Cool. All right, it's over. It's done. It's 5:20. I should probably head to the theater since I'm so far away. It's cold out and dark. And I should get some food while I'm there, because I can't make any food. Or I should just go hungry. I'll get there and I'll take a look at what's good and what's not good. But this is good. Good job, guys. So if I look up LEET code, I get LEET code, right? Which is easy problems. The slug pre-fills it. Even organizes by frequency. Wow. Crazy. All right. Let me end this video and upload.